Okay, breaking a quotient into two parts, I see the integral of 1 plus cosine e to the negative 2x all over e to the 2x dx. If this was just cosine e to the negative 2x over e to the 2x, that'd be an easy u substitution. If it was just 1 over e to the 2x, that's an easy u substitution. But right now we have this sum all over e to the x, so we'll break it into two parts. Now when I rewrite this, I'll rewrite it as 1 over e to the 2x. Instead of saying that, I'll write it as e to the negative 2x dx. And then we are going to add to that the integral of cosine of e to the negative 2x all over e to the 2x dx. Here is an easy u substitution. We'll let u be negative 2x, and du then is negative 2 dx. I don't quite have each piece of my du. I only have the dx, so I'll put a negative 2 here, but I can't just write a negative 2 there. Multiply by negative 1/2 on the outside. Therefore, I haven't changed my integral. Over here, another u substitution, but I don't want to use u because I've already used u in the first integral. So I'll pick another variable. It doesn't matter. And I'm going to choose z. I'm going to say z is equal to the e to the negative 2x. That's in the cosine function. Therefore, dz is negative 2e to the negative 2x dx. And again, I don't have each piece of my dz. I have the dx. I have the e to the negative 2x. I just need a negative 2, so I'll write that here. And again, I'll multiply by negative 1/2 on the outside. Now when I go to rewrite, it'll be negative 1/2 the integral of e to the u du, and then minus 1/2 the integral of the cosine of not u, but in this case z dz. When I integrate, negative 1/2, the integral of e to the u is e to the u minus half. The integral of the cosine of z is the sine of z plus c. Now we're just going to resubstitute our u's and our z's. This is negative 1/2 e, u is negative 2x minus 1/2 sine of e to the negative 2x, and then we have plus c. Going forward, we have integrals involving sum or differences of squares. In this case, 16 minus x to the 6th underneath that square root. We have an x squared in the numerator. I'm looking at this, and immediately my mind is drawn to a arc sign in this case. I was thinking initially, hey, maybe u substitution, but if we let u equal 16 minus x to the 6th power, well, du was going to be giving us a 6x to the 5th. Clearly, we do not have that up there. So what we can do is I'm going to rewrite this as the integral of x squared all over square root of, instead of 16, I'll write 4 squared. And instead of x to the 6th, I'll write x cubed raised to the 2nd power dx. Now when you're integrating and you're going to be getting any kind of arc trig function, if this is anything other than x squared, you're going to want to do a little u substitution. So we'll let u equal x to the 3rd power. Du then is 3x squared dx. And I like this very much because I have an x squared dx in the numerator. Just need my 3, multiply by a 3rd. And so this ends up becoming a 3rd, the integral of 1 over the square root 4 squared minus u squared du. Now we're ready to integrate. That's a 3rd, the arc sine of u over 4 plus c. And then you just resubstitute our u, and so this is 1/3 the arc sine of x to the third over 4 plus c. An integral in disguise, we have the integral of 1 over 1 plus e to the x. Initially I might think, oh, maybe it's a u substitution with u being 1 plus e to the x, but if you take your du there, you're going to get an e to the x dx, and we do not have an e to the x in the numerator. So what we can do here is we can add and subtract an e to the x in our numerator. And so what I'm going to do now is I'm going to group a couple terms together when I rewrite this. This is going to be the integral of 1 plus e to the x. I'm going to group those together. There's my minus e to the x all over 1 plus e to the x dx. So that when I simplify this, we'll have 1 plus e to the x over 1 plus e to the x. Well, that's just the integral of 1 dx, and then minus the integral of e to the x over 1 plus e to the x dx. This here, u substitution, u is equal to 1 plus e to the x, therefore du is e to the x dx. We like that very, very much. And so I'll go ahead and rewrite my integral as the integral of 1 dx minus the integral of 1 over u du. And so this is equal to integral of 1 dx is x minus the integral of 1 over u du is the natural log of the absolute value of u plus c. Now I'm going to resubstitute my u, and so this becomes x minus the natural log. I don't need the absolute value anymore because 1 plus e to the x is always positive, and then plus c.